Well, hello there again, my awesome, amazing students. So, this week we are going to be talking about atmospheric convection. So, what is atmospheric convection? Well, it's the way that those different heats are transferred throughout the atmosphere coming from the huge source of what? The sun, right? The sun is our energy master. So we're going to go over a few things. The sun's energy being number one. Have you ever stood on a sidewalk in a hot, sunny day while not wearing shoes? Now, you could think even of a beach. If you ever walked on the beach in the summer, the sand, right? Your feet, oh, it's hot, 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 hot. You're trying to hurry up and get to some shade, right? Because your feet are cooler than that bottom, right? It's the sand is hot or the ground is hot. So what is that? That is heat transfer, thermal heat transfer. Heat is always going to go or gravitate toward cooler areas, all right? And this is pretty much what we're going to be talking about. In the atmosphere, you have heat that is going to always go toward cooler areas. Wherever it's cooler, that's where the heat will flow, okay? So, Earth receives its energy from the sun. The sun energy travels to Earth in the form of radiation. Radiation is the transfer of energy as electromagnetic waves. Okay, let me say that again. I hope you're taking notes. Radiation is the transfer of energy as electromagnetic waves. Radiant energy reaches the Earth in the form of both visible and invisible electromagnetic waves. Although the sun releases huge amounts of energy, the Earth receives only a small amount of this energy. Only a small amount, okay? Good thing we only receive a small amount. Can you imagine if we received all of the radiation from the sun? We would not be here, okay? So the diagram below, right here, shows what happens to the sun's energy once it enters the atmosphere. So if you look here, it says about 20% of the sun's energy is absorbed by ozone layer, clouds, and atmospheric gases, right? Then it says 25% of the sun's energy is scattered and reflected by clouds and air. Right here, it says about 5% of the sun's energy is reflected by the Earth's surface. Okay. And look here, it says about 50% of the sun's energy is absorbed by the Earth's surface. Okay. Easy, easy, easy. So it says right here, what percent of the sun's energy is absorbed by Earth's surface? So you're going to pretty much test yourself. I just said what it was. Of course, you know, right? So I'm going to also have this link in your folder because you are going to go through this on your own. This is an interactive exercise and make sure that you use it to your benefit. Okay? After the energy from the sun has reached the earth, it is transferred to other objects in one of two ways. It's either going to be conduction, right? It's when you have heat transfer, thermal heat transfer. It's going to be hot heat. It's going to be leaving and gravitating towards something cooler, right? So, conduction is the transfer of thermal energy from one material to another by direct contact. So, that means in order for conduction to take place, objects have to touch. If you ever touched a hot pot, your hand is cold or cooler than that hot pot. So, when you touch that handle, you're going to feel that heat. That's conduction, okay? So this example right here pretty much shows you if it's 25 degrees Celsius and it's going to go in the direction of something cooler, then it's going to be considered conduction. So it's always going to be the hotter temperatures going toward the cooler temperatures. Keep that in mind when we think and talk about weather maps and weather systems, okay? So you're going to continue reading through all of this, right? It says on a hot day, the sidewalk heats up from the sun, right? Because the Earth's surface is absorbing some of the sun's energy through radiation. Okay. Then look at this picture here. It says hot liquid rises while cool air or cooler liquid sinks. If you ever had some coffee or some tea, what are you trying to do? You're trying to blow it so it can cool off. Well, what you're actually doing is creating convection currents in your cup. So if you have a hot beverage and you're blowing it, that hot heat or liquid at the top, as it cools, it goes down, right? So it's going down and it's a constant current taking place until it cooled off. Yep, you can make your own convection currents right there in your cup. All right, so let's talk about why air moves then. So you have what are called pressure belts. Warm air is less dense and rises, while cool air is denser and sinks. Take notes. Look at the diagram below. Imagine that the circles in the Meyer flask are air molecules. The image on the left shows the molecules when the air is cool, right? This is when the air is cool. And then the image on the right shows the molecules when the air has been heated. So what is happening? It's going to rise. It's going to rise. When the molecules are heated, they move faster and they move apart, causing them to be less dense and rise. Okay. Right here, this is a really, really cool video, and I'm going to go ahead and play it and talk as it goes. There's no sound to it. So what's happening here, they're going to use food coloring. Now, this is cold water. So the food coloring is placed inside of the container. Notice it's right there in the container. Now, they're going to take and put hot water in a cup. Now, this water is hot. So what they're going to do is they're going to place the hot water underneath the container where the food coloring is and watch what happens. Okay, right now it's cool. The food coloring is cool. But now they're going to place hot liquid underneath it. So let's see what happens. Ooh, better be careful. Ooh. So as the food coloring begins to heat or warm up, notice what it is doing. It is rising, okay? But before it was cool, so it was staying where it was, right? Cooler air sinks, warm air rises. All right. Please do not try that at home unless you ask your parent and have supervision. Okay, so we are going to go ahead and move on. So wind is the moving of air and is created by differences in air pressure. And I want you to read through this on your own. Also, right here talks about how the high pressures come from the poles, okay? You have to understand the illustrations that you're looking at. So you need to read through the material, guys and girls. All right? Right here, we're talking about those different cells, and you'll need to understand these cells when we talk about the Coriolis effect coming up next. So cold air sinks at the poles. Notice cold air sinks at the poles. As the air moves away from the poles and along Earth's surface, it begins to warm and the pressure drops, okay? This drop in pressure creates low pressure belts around 60 degrees north and 60 degrees south latitude. So that's going to be right here, 60 degrees north, and right here would be your 60 degrees south latitude, okay? Latitude, not longitude, but latitude, okay? So I'm going to let you all continue reading on your own with that. Once you complete that reading, you're going to check your understanding. Now notice this is a drop-down box, so you would pretty much just choose your answer for every single one, and you would press submit, okay? Once you press submit, you will have your right or wrong answer shown to you. I did not put any answers, so clearly they're all wrong for me, but you're going to get them right, okay? So why air moves, part 2, Coriolis effect. Now, about the Coriolis effect, and I'll let you watch this on your own, but just to show you really quickly, when we think about the Coriolis effect, the best example that I can give you is let's see, the best one would be the merry-go-round. The merry-go-round. So if you're on the merry-go-round and you're throwing a ball to someone across from you, will the ball go straight to that person or will it curve? There's another video in your lessons. I'll let you answer that on your own. Okay? Please make sure you read on the Coriolis effect. So the Coriolis effect is the perceived change or disillusion in the direction of the currents caused by Earth's rotation. Now, please remember that very first sentence. Take notes. The Coriolis effect, it all depends or it is caused by Earth's rotation. Okay? We have to look at the direction that the wind was moving due to uneven heating. So you're going to click the boxes below to look again at the diagram of the wind direction because of uneven heating. Remember, these are your interactive exercises. You are going to complete them. Okay? Then you have another check your understanding here. All right, so types of winds. We have global winds, we have local winds. Global winds are all around the world. Local winds are specific for that geographic area. All right, for example, Texas has local winds. All right, the world has a global wind. Okay, and these winds are called trade winds, westerlies, and polar easterlies. And you will have a diagram that shows you what these are. Okay. Now here's a practice for you right here, but this is your answer key right there. You will simply drag and drop. See if I can get this. Gotta click on it. Drag and drop it on one of the question marks until you used every single one, and then it's going to automatically tell you if you're correct. If you want to start over, all you have to do is press the reset button. Okay. So local winds, like I said, that is local for that geographic area. All right. It's very different from global winds, which are all around the globe, right? All of those different prevailing winds, trade winds, easterlies, westerlies, right? So these are your local winds. Make sure you read on that. It also talks about sea breeze and land breeze. Sea breeze, oops, we didn't want to do that. Let's go back. Sea breeze, this is going to be the cool breeze coming from the water, right? Excuse me, and going toward the land. This is why if you're walking on a beach and the wind is blowing, it may feel a little cooler. Yeah, because water is going to always be cooler than land. Now, what if you have land breeze? Well, it's the opposite. It's going to be a breeze blowing from the land towards the sea. And this can sometimes be warmer air, right? So it's kind of that interchange or it's kind of balancing things out. It's uneven heating, right? Okay. And again, you have a lot of illustrations and examples. Please do your reading. All right, now we're on currents in the ocean. The sun also provides the energy that drives convection in the ocean and produces ocean currents. The sun is the boss of just everything, okay? You can't have this world without the sun, so we need the sun for just about everything, all right? So you're going to go ahead and finish talking about surface currents, global winds, which are near the equator. The winds blow ocean water east to west, but closer to the poles. Ocean water is blown west to east. Okay, so when you're closer to the poles, the water is going to go from west to east. Okay, it's almost like that mirror image when you think about the Coriolis effect. It's like what's happening in the north is the same thing that's happening in the south, but it looks like it's going in different directions when in all reality it's really going the same direction, but because it's two different hemispheres, it's almost like a mirror effect, right? Okay. Okay, these right here are going to talk about those different currents, deep currents, You have surface currents. Warm water from surface currents replaces colder, denser water that sinks to the ocean floor. Remember, I was telling you colder water is going to sink while warm water will rise. Same thing with air. Cooler air will sink, warm air will rise. Okay. And that is going to be the end of your interaction page on Texas Gateways. Please make sure once you're done with this video and you've taken some notes, you go in and complete the activities on your own. Everyone have a great rest of the day. Do not allow yourselves to get behind. Bye-bye.